On the next equation, this is the first one I have to set equal to 0. It's not set up for me. So I'm going to move over the 29x squared. I'm going to subtract it to the other side. And I'm going to add over the 100. This one, we see that same structure where we can still find adding and multiplying. But we are going to put x squared in the front because this is a quadratic equation. So factors of 100 that add up to negative 29 are negative 25 and negative 4. This is another one, right? We could factor this further because it's difference of perfect squares, but honestly I use square roots when I can, whenever it's incomplete. So this is plus or minus 5, and this one over here is plus or minus 2. Can write those out. And 5. Once again, order doesn't really matter. I try to write them in order from smallest to largest, but it's fine either way. The next one, we have a GCF, so I'm going to take out a 5x. And then this is, if I divide by 5, that's going to give me 32. So here we have a 5x. This is that same structure, so we're going to find adding and multiplying here. So this is x squared minus 8 and x squared minus 4 for this one. 5x, we know is going to give us an answer of 0. Moving over to x squared minus 8, I have x squared equals 8. So when I take a square root here, if I simplify this, 8 is 4 times 2. So we're going to get plus or minus 2 radical 2. On the last piece, we get x squared equals 4. So x equals, when we take that square root, plus or minus 2. So long list of answers here. We have negative 2 square roots of 2, negative 2, 0, 2, and 2 square roots of 2. Now our next one is already factored for us, which is nice, right? So we don't have to multiply it out. We know we're trying to use the zero product law. So when I set this one equal to 0, this is our first one where we're encountering a negative square root. So, and that will actually come up in some of the rest of them. So when I take a square root here, I'm going to get plus or minus 3i because I have the square root of negative 9. This answer is just going to give me x equals negative 3. Now there's a fact about imaginary numbers. They're actually not orderable because they aren't on the real number line. So you can try to put them from smallest to largest, but it doesn't really even make sense to put them from smallest to largest. So really with these, you can put them in any order you like. Moving to the next one, we're going to take out an x. And we have x squared plus, or x to the 4th, plus 6x squared plus 8 equals 0. So here we're trying to find factors of 8 that add up to 6. So we have our x, we have our x squared plus 4, and our x squared plus 2 will work. So here this one gives me 0. Here, this one's going to give me x squared equals negative 4. Square roots, we get plus or minus 2y. And this one is going to give me x squared equals negative 2. When we take a square root, we know we need to take out the I, but 2 is not a perfect square. So this is plus or minus I radical 2. Don't really have room. I could split these up and write them all in the brackets, but these are the 5 answers to that one. And we have about 3 more. So in this one, once again, it's grouping. We haven't done a grouping in a little while. We've had a lot of those x to the 4th ones. So here I take out an x squared, and I have 2x minus 3. Here I'll take out a positive 1, and 2x minus 3. Common binomial factor, and we have x squared minus 1 left. So this one, linear, is going to give me positive 3 over 2. Here I have x squared equals a negative 1. Now, don't be silly here, right? We're not going to write I radical 1 or anything crazy like that, right? The square root of negative 1 is just I. So this is plus or minus I here. Don't leave like I square roots of 1. The square root of 1 is 1, right? So we have 1 I left here. So here's my 3 answers. Now the next one's a little tricky, right? This one is easy, right? If we split this up, it's already factored. So I can do x squared equals 9, take a square root, and we get x equals plus or minus 3. This part over here is a quadratic, but looking at it, there are definitely no numbers that add up to 4 and multiply to 1. So when we see something like that, just like last unit, we have to say, well, I can't factor it. It's a quadratic. I need to use the quadratic formula. So I'm actually going to move that one down here. Our quadratic formula is negative b, so negative 4, plus or minus the square root of 4 squared minus 4 times a times c, right? Our a is 1 and our c is 1, all over 2a. So this is negative 4 plus or minus. This is 16 minus 4, so it's radical 12 over 2. Negative 4 plus or minus. Radical 12 is 4 times 3, so when I simplify the square root of 4, I get 2 radical 3. So I know I skipped a step there, but just wanted to save a little space. Then we can simplify, right? So I get negative 2 plus or minus radical 3, because those 2's cancel. So just to kind of clean this up, and this is part of the reason we sometimes use the brackets, because sometimes our answers are all over the place. I have negative 3, I have negative 2 minus radical 3, which is technically smaller than negative 3, but that's fine that I wrote it here. I have negative 2 plus the square root of 3, and then I also have positive 3. So those are my 4 answers. Don't forget about those 2 we found up here. And then this simplified into just negative 2 plus or minus the square root of 3. Last one, we see that this is a difference of perfect squares, right? We did this in the beginning, or in unit 2. So this is 4x squared plus 5 and 4x squared minus 5. Now you could try to take a 4th root here, but that's even more complicated than having to think about a plus or minus. You have to think about 4 answers. Some of them are imaginary, some of them are not. So get it down to at least quadratics before you try to do anything with incomplete. So I'm going to set this one equal to 0 first, and I'm going to write out the whole thing, or at least write it once. So here I'm going to subtract 5 and divide by 4, and I get x squared equals negative 5 fourths. Then we'll take a square root. So I have plus or minus. The square root of negative 5 is I radical 5. The square root of 4 is just 2. Okay? Now I actually prefer to write this one just with the I after. I think it looks better. So that's where I'm going to put it. It doesn't really make a difference. So this is plus or minus radical 5 over 2i. Over here, if I solve this one, instead I'm going to get x squared equals positive 5 over 4, right? We'll move that same fraction over, take a square root, and I get x equals plus or minus radical 5 over 2. So we'll put answers down here. Here's my imaginaries, negative radical 5 over 2i, radical 5 over 2i. We have negative radical 5 over 2 and radical 5 over 2. For answers, quadratic equation, right, all that kind of matches up.